Okay, pause the video and write this down. Okay, we're translating from English into math here. So what do I got? I have a barn. Let's assume it's a rectangle. Whatever, rectangle. That's my lovely barn. And then I have a rectangular plot adjacent to the north wall, so the top wall. So I got a plot of land, say like this. And I see the word area down here, so why don't I just go ahead and put a Y here and an X here. Okay, then I'll read again. So I don't need any fencing along the barn, so I don't need fencing here. And the fencing along the kind of left side here is half price, we'll say. So what is area? Area is X times Y. And it says most area. So I want to find the absolute max of A, my area function. Area has two variables, which is not a good thing. So how can I eliminate one of those variables? Well, I got to use these numbers here. So looks like I have some kind of a cost function. So 5,000 is all that I'm willing to spend. And well, how much am I going to spend when I fence this area? Well, the top wall is going to cost me 20 times X. Okay, the wall on the right is going to cost me 20 times Y. The red wall is it's half price, right? So 10 times Y. And the blue wall is 0, right? Because it's no need to put a wall there. Okay, so again, the amount I'm willing to spend is 5,000. Here's the amount for the top wall of the plot. Here's the amount for the right wall, black wall. And here's the amount for the red wall. Half price, since my neighbor is being such a gentleman. Okay, so what do I want to do here? Divide by 10, eh? 500 is 2x plus 2y plus y. So 500 is 2x plus 3y. So I can eliminate x or y, doesn't matter. I'll just eliminate y, or I'll solve for y here. So that's 500 minus 2x all over 3. So area is xy is x times 500 minus 2x over 3. So here's my function. Area as a function of x is 1/3 500x minus 2x squared. So I got my function. What is the interval? Okay, we're going to use the closed interval method again. What is the interval? Okay, x is a side length, so it has to be at least 0, right? And what's the most x could be? Well, let's just not worry about that for the time being. Let's see what we can do without that. 5,000x, what's the highest? Well, I guess x could be, we'll come back. That seems like a waste of time to talk about that for now. Let's have a look at our function. So I use the closed interval method. I'm missing an endpoint, but we'll see if we need it. Okay, 1. Critical numbers. Well, a prime of x is a third 500 minus 4x equals 0. Gives me 500 over 4 is x. X is 125. Units, who cares? Meters, I think, but so that's my only critical number. Area. What's the area? So I'm looking up. I'm gonna look. Where am I gonna plug this in? I'm gonna plug it in here. Here. So what do I get? 125, 250 over 3, which is not a very nice number. Let's just leave that alone for now. 125, 250 over 3. Yeah, let's just leave that alone for now. Double check my answer here before I go any further. Yeah. So this is some number. You can use your calculator to sort that out. Now I would check the endpoints. I'm going to say there's no need, right? There's no need to check endpoints since look at a of x. A of x is a parabola facing down. So it looks something like this, right? So I've found, I know just by looking at a, I got, it's a parabola, right? I got negative of the x squared term. So it's a parabola facing down. So what I've found here is the max. So this is a little shortcut. 3. There you have it. That's it. Absolute max is, whatever this number is, 125.250 over 3. I'm going to say meters squared. Meters? Wouldn't use feet, would I? Foot. Oh, it is feet. That's awful. It's American textbooks. Feet squared. That's my maximum area I can achieve with this budget constraint. Just as a technical point, if I wanted to find the endpoint here, my reasoning would be something like, okay, how large could x be? This is getting a bit abstract here. So if I'm looking at this diagram, you could have y is equal to 0, right? So you can have something like 5,000 is just all x. If I take this equation, if I set y equal to 0 in this equation, that's the largest x could be. So x would be, what was that, 25? 25 feet. 25 or 250, 25 or 250. 250 feet. So this number here, if you were so inclined, you could reason like that. But that was not necessary because I noticed that the parabola was facing down.